So, whether the NFA is more powerful or the DFA is more powerful is still a point of a debate. We will discuss that topic in some other course. Here I am going to discuss about how this DFA is going to accept some strings and what are the properties of that DFA and NFA, and what kind of language is accepted by the NFA. So if we analyze this NFA, the question comes in mind: what kind of language this NFA is going to accept, right? And how we are able to analyze that. So once again, let's first think about some input and then test it whether that input is acceptable by this machine or not. So let's see, the input is 0 1 0 1 1, right? So let's see whether this input is acceptable by this particular NFA or not. So let's start. Here the start symbol is A, so we need to start with A, and the string which we are going to process, the symbol which we are going to process from the input string is 0. Now we have the two choice. Possibly we will go with this this direction by following this branch, or we can go with this branch, right? So we have two possibilities that we can show like this. So we have two possibilities: 0, either we stay at A, or the machine may move to the state B. Now if the machine decides to stay in A, then the next symbol which we are going to process, or the machine is going to process, is 1, and then there is no choice, the machine needs to stay in A. But if the machine decides to stay in B, then it will go to the state C. Now then the machine needs to process the symbol 0, this 0, and then again the machine has two choice. Here, if the machine to decide in A, that is, it will go to A or it will go to B. Let me write it out on here: 0 1 0 1 1. This is the input. So now 0 1 0 0 1 0. We have already processed this one, and if the machine decides to stay in stay in C, and it is processing this 0, the machine go to the state B. Now the machine need to process this 1, and if the machine state is A, then there is no choice, it will stay on A, right? But if the machine decide to stay on B, and then by following A, the machine go to the state C, and then the machine need to process the 1. Here is only one choice, we need to go to A. If the machine stay in C, then there is no choice and the machine will crash. But machine decide to stay in D, then there is no choice for 1 and the machine crash. Okay. So by processing this input 0 1 0 1 1, the machine either crash by following these two direction or stay in A. In both cases, the machine is staying only in a non-final state. Machine is not going to the final state, right? So in this case the input, this input should be rejected, right? Now let's take another example to analyze what kind of a string it is going to accept. So let's take the input like 0 1 0 0 1 0. So let's think about this input and let's see how the machine is going to compute this. So machine is going to start with A as usual because that is the start state, and then by processing this 0, the machine again has the two choice 0, either it stay in A or it go in B. Now then the machine need to process this one, and then machine has no choice, it will go to the state A itself if it is deciding to stay in A. But if the machine is staying on B, then by processing this one, the machine is going to state C. Then the machine need to process the 0. Then by processing the 0 from the state A, again we have the two choice, either stay in A or go in B. But if the machine is in state C, by processing this 0, the machine is going to the state B. If the machine is staying in A, then by processing this 0, the machine can have two options again, either it go to the state A or it go to the state B. Now then the machine need to follow 0 1 0 0. So machine is already completed this one. Machine need to follow 1. From A we don't have any choice, stay in A. From B we have only one choice, go to state C. There is one more thing. If the machine is staying in B and it need to process 0, then it crash, right? Now machine is in state D and it need to process 0, then also it is crash. So now machine has followed this one. The machine is going to process 0. From A there is again two choice, either it go to A or it go to B. From C there is only one choice, it go to D. Now if we analyze this, there are some branches called this branch is going to the class, this branch it is also going to be to the class part. If we analyze this branch, it is going to stay in the state A, that is again the start state, it is not the final state. Now if we analyze this, then again the machine is going to stay in the state B, right? That is also a non-final state. But if we analyze this branch, then machine is starting from the A, start symbol A, going to the final state D by processing all the symbols from the input. So there exists one branch which is going from final start state to final state by processing all the symbols from the input. So we say that 0 1 0 0 1 0 is accepted. Okay, so this particular string is accepted. Now, so what we have figured out, a string something like 0 1 0 0 1 0, it is accepted. Now if we again see this particular NFA, what we realize, the machine is accepting or processing this particular state. If we talk about this particular state, this state process all 0 and 1. But if this state is able to process all the 0 and 1, then what these states are processing? So these states are processing nothing but the last three symbols. Okay. So this particular state, if this particular state, the A, so if I say A process all the zeros and 1 except last three symbols, and if last three symbols are 0, 1, 0, then we or the machine may go to final state, right? Machine, if this particular state process all the zeros and 1, say if we analyze this particular input, if this three symbol, that is not the last three symbol, all symbols except the last three one will be processed by this, and then the last three symbol will be processed by this state, then there is a chance that we can go from start state to the final state, right? So if this is happening, then we accept all the strings, or this machine will accept all the strings ending with 1, 0, 1. So this particular NFA will accept the language L in which there is a string. A string is made of 0, 1 star and W ends with 0, 1, 0, right? So this particular language is accepted by this particular NFA. Let's test it out whether all the strings which is ending with 0, 1, 0 is accepted by this machine or not. Let's take one more example. 1, 1, 0, 0, 1, 0, right? So this particular if this is the input, then how the machine will behave? Start with A, so machine is starting with A, and then machine need to process this one, so there is no other option, the machine will go to the state A. Then machine need to process this one, so it will go to the state A. Now the machine need to process this 0, machine has two choice, either it go in the state A or it will go in the state B. Then machine need to process this 0. If the machine is in A, then again there is two choice, either it stay in A or it go in a B. But if the machine is in B state, by processing this 0, the machine crash, right? Now machine need to process this one, and from this A there is only one option, it go to the state A, but from this B option the machine can go to the state C. Now the machine need to process this 0, and then from A there is two choice, either it go to the state A or it will go to the state B. From C there is only one option, it go to the state D. Now if we analyze this branch, then what we find, the machine is starting with the start state A and going to the final state D by processing all the symbol, right? So in this case what we can say, 1, 1, 0, 0, 1, 0 is accepted, right? So in that way we can analyze any string which is ending with will be accepted by this particular machine, right? But by simply designing the NFA is little hard, because from various states we may have multiple choice, right? So designing NFA is hard. It is better to design DFA if it is directly possible, right? Okay. So in the next video, I will talk about conversion from NFA to DFA if it is possible, and some more problem on NFA. Thank you.